Hello everyone, I am NALINAKSHAA from BE G2 third year and I am here to explain the solution for the problem provided to me at RECode contest conducted by Coding Club. So now let's quickly move on to the problem statement. The problem is that given a partially filled 9x9 2D array, our goal is to assign the digits from 1 to 9 to the empty cells so that every row, every column and every subgrid of size 3x3 contains exactly one instance of the digits from 1 to 9. And we are asked to write the program for the same. So now let's quickly move on to the code constraints. The first constraint is that all elements in a row has to be unique. So as an input, we will be given with a 9x9 board and our first constraint is all elements in a row has to be unique. So as we can observe in our sample output, we will be having 9 rows and 9 columns. So our first constraint states that in all these 9 rows, in each row we can't have any numbers which are being repeated. That is, all elements in a row has to be unique, which is our first code constraint. And the second code constraint is that all elements in a column has to be unique. So in all these 9 columns, we can observe that we couldn't find any repeating elements in each column. So this satisfies our second constraint. And our third constraint is that all elements in a 3x3 grid has to be unique. So we are given with a 9x9 board as an input. So a 9x9 board will be consisting of 9 3x3 subgrid, and our third constraint is that all elements in each 3x3 subgrid has to be unique. And now let's move on to the fourth constraint. It states that each element can have values ranging from 1 to 9. For the given 9x9 board, we can have any values from 1 to 9 in each cell. That is, we can't have any values out of the range 1 to 9 in a cell. That will be a fourth code constraint. So now let's move on to the sample input and the output. So in the input given to us, we are given with a 9x9 board and we will be having some values in the range of 1 to 9 and some values filled with 0. And these values in range of 1 to 9 are called as pre-filled values which are given to us for solving this puzzle. And the values with 0 are the values which are empty. So 0 will be considered as an empty cell. And now our task will be to replace this value 0 with any one of the values from 1 to 9 such that it satisfies the 3 constraints that I specified in the previous slide. So this will be my sample input and that's the task that I will be performing, and I will be arriving at the output that I specified in the right hand side. That is, in the output I will be having all the values in range from 1 to 9 such that it satisfies the 3 constraints that I specified in the previous slide. So if we keenly observe this problem, we can come to a conclusion that this is nothing but the Sudoku puzzle that we solve in our day-to-day lives. So I hope most of you might have solved Sudoku puzzles in backside of your notebooks. So you will be given with a 9x9 board again and you will be having some pre-filled values and some cells which are being empty. And now our task will be to fill these empty cells with one of the values from 1 to 9 such that it satisfies the 3 constraints that I specified in the previous slide. So that's the thing we'll be doing. So we'll be starting with the first empty cell and we'll be moving on by filling with some value, valid value from 1 to 9. So we'll be reaching a particular state where we couldn't find any valid value. That is, replacing that value 0 with any one of the value from 1 to 9 leads to the violation of any one of the 3 constraints, at least any one of the 3 constraints that are specified in the previous slide. So this case, what we'll be doing? So in this case, we'll be just leaving that value and we'll be moving on to a previously filled blank cell. So in that previously filled blank cell, we'll be trying to replace with some other value so that I can have some valid value in my current cell or the next cell. So this process where I couldn't find any valid number in my current cell, so I'm moving on to the previous cell and I'm replacing it with some other value so that I can add a valid value in my current cell. So this process that I follow is called as a backtracking, and that's the one I think you will be following while solving the coding Sudoku puzzles in your notebooks, and that's the approach that I'll be using in solving this puzzle in my code too. So now let's quickly move on to the algorithm. So the first step in the algorithm will be to initialize the hash set. So as we all know, hash set will be the data structure in order to retrieve the elements or in order to make sure what are the numbers which are being present in the set with an order of 1 time complexity. So now the first step is to initialize the hash set for row, column and 3x3 subgrid in order to keep track of the used numbers. So as I said in the code constraint, each row should be having the elements which are being unique. In a similar way for the column and 3x3 subgrid too. So as we consider here, we are having 9 rows, 9 columns and 9 3x3 subgrids in a 9x9 board, which means that we'll be needing 9 hash sets for row, 9 hash set for column, and similarly 9 hash sets for 9 3x3 subgrids. So totally we'll be having 27 hash sets, and our first step is to initialize all these 27 hash sets in order to keep track of the used numbers. And our second step will be to traverse the Sudoku grid, and after that, for each non-empty cell, we will be adding that number to its corresponding row, column and box set. So our third step is, so here the non-empty cell will be the one with the pre-filled values, that is the one with any one of the values from 1 to 9. And our third step is to place all these pre-filled values into their corresponding hash set. So this is in order to keep track of the used numbers. So let us consider an example. So 3 will be my first pre-filled value. So 3 is present in first row, first column and first 3x3 subgrid. So I will be adding 3 to my first row, first column and first 3x3 subgrids hash set, so that I'll be enforcing a constraint that I can't add 3 in my first row, first column or first 3x3 subgrid in my next or further computations. So in the similar way, I'll be adding all the pre-filled values in my 9x9 board to the corresponding hash set. So that will be my third step. And after that, for any empty cell, attempt to place the numbers from 1 to 9. This is my fourth step. So now my first empty cell as of this 9x9 board will be the one which is in first row and second column. So I'll be replacing that value with any one of the value from 1 to 9. The important thing is that it must satisfy the 3 constraint which is provided in the step 5. For each number, check if it's not already in the current row, column or 3x3 subgrid. So let me explain this with an example. So let us consider this board where I've solved from 1 to 6 rows and I'm currently in my 7 rows. So in my algorithm, I've used an approach such that I'll be solving all the empty cells in the row wise. That is, first I'll be solving all the empty cells in row 1, row 2 and so on. So as of this example, I've solved up till the row 6 and I'm currently in the green position in my row 7. And I have to replace this value 0 with some valid value from 1 to 9 such that it satisfies the 3 constraints. So for that, first I'll be starting the iteration with number 1 and I'll be checking if it is present in the row or not. So in a similar way, I'll be checking for 1, 2, 3, 4 and 5 and all these numbers are present in my row. So my first non-found value in the row will be 6, the value 6. So now I'm checking with the value 6 in my column as well as the 3x3 subgrid. So I didn't find 6 in the column as well as I didn't find 6 in 3x3 subgrid, which means that the number 6 satisfies all the 3 constraints, so that I can place 6 in place of 0. So that will be my next step. So here they have said, if valid, place the number in the cell. I will be placing 6 in place of 0, which is my next step. And after that, what should I do? I have to update the row, column and box set with the place number. So after placing 6 in place of 0, I shouldn't place 6 in the corresponding row, column and 3x3 subgrid. So 6 exists in, it is in 7th row, 6th column and 8th 3x3 subgrid. So I will be adding 6 to the 7th row, 6th column and 8th 3x3 subgrid, so that I couldn't add 6 in my next computation in these corresponding rows, columns and 3x3 subgrids. So this will be my next step. And after adding, I will be finding the next non-empty cell which will be 0 in the same row at the end. So now I have to replace 0 with some other value from 1 to 9. So again I will be checking from the value 1 to 6 and all these values are found in my row. So my first non-found value in the row will be 7. So I will be checking with 7 in the corresponding column, which is the last column. I find 7 in the column as well as in the 3x3 subgrid. So it violates my 2 code constraints. So what should I do? I shouldn't place 7 in place of 0. Which means that I will be checking with other 3 numbers, which is 8 and 9. Other 2 numbers, 8 and 9. So I find 8 and 9 in the row, which means that I can't place 8 and 9 too. So I have ended up in a condition where placing any number from 1 to 9 leads to the violation of the code constraints. So now what should I do? So as per the algorithm that I have explained, we will be moving on to the previous step. So my previously filled empty cell here will be 6, right? So I will be replacing 6 with some other value so that I can place some valid number in place of 0 in my next step. So now I will be trying to replace 6 with some other value here. So now I will be replacing this 6 with 0 again. That is, 6 is not a valid one in my previous step, so that I didn't arrive a valid value in my next step. So I will be replacing 6 with 0 and I will be finding another valid combination instead of 6. So iterating through the row, I find all the numbers from 1 to 5 and 6 is not the valid one. So now I will be trying to place the number 7. 7 is not found in the row, column as well as the 3x3 subgrid. So I will be trying to place 7 in the place of 0, and this is a valid one. And now I will be trying to fill the 0 which is in my right hand side. So I will be replacing it with 7, and after replacing it with 7, our main step is to add the 7 to the corresponding hash set. So 7 is actually present again in the 7th row, 6th column and 8th 3 cross 3 subgrid. So I will be adding it to the so before adding 7, the main step is that here we removed 6, right? So we have replaced 6 with the value 0, which means that 6 is no more present in the 7th row, 6th column and 8th 3 cross 3 subgrid, which means that we have to remove 6 from the corresponding hash set. So this will be the step that I will be following after replacing with 0. And after replacing with 0, I have found the valid one which is 7, and after replacing it with 7, I will be adding 7 to the corresponding hash set. That is, I will be adding 7 to the, it is the 7th row, 6th column and 8th 3 cross 3 subgrids hash set. So this will be my next step. And after adding 7, I will be finding my next empty cell which is 0 present in the last column of the same row. So now I have to replace 0 with some other valid sequence. So on iterating from 1 to 9 along the row, I find all the numbers from 1 to 9 across the row. The first non-found number in my row will be 6. So now I am trying to place 6 in the place of 0. So now I have to try with the column 2. So that column also doesn't consist of the value 6, and the 3 cross 3 subgrid also doesn't consist of the value 6, which means that it is valid to place 6 in the place of 0. So now I will be replacing the value 0 as 6, and after replacing it, our task is to add it to the corresponding hash set. So 6 is present in the 7th row, 9th column and 9th 3 cross 3 subgrid. So we will be adding it to the corresponding hash set. So this will be the approach that we follow in order to solve this Sudoku puzzle. So this is the actual algorithm where we will be recursively attempting to solve the rest of the puzzle, which is the 9th, 8th step. And after that, if the grid is completely filled, we will be returning the solution, which means that we have completed the Sudoku puzzle. Otherwise, if a conflict arises, that is no valid number can be placed, which I have discussed now, we will be backtracking by removing the last placed number. So this is what I have discussed in the working there. And after that, we will be repeating this process until the puzzle is being solved or no solution exists. So there will be a case where the pre-filled values in a board are such that we will be having some valid solution. So in such case, we will be returning a valid board like as this. We will be having the output. So in some cases, the input will be such that we can't arrive at any valid solution satisfying all the 4 constraints. So in such case, we can return a result as no solution exists. So this is what is specified in the 11th step. So now we will move on to the code now. So I have coded using the Java programming language, and now let us move on to the main function first of all. So in the main method, so first I have initialized the 9x9 board which I will be using for obtaining the input. So my next step is to obtain input, which I have done using the 2 for loops. So after receiving the input, 9x9 board will be such that some values will be pre-filled and other values which are 0 will be the ones which are empty, and our task is to find or replace a value of 0 with some other value from 1 to 9 such that it satisfies the constraints. So after the 2 for loops, I am ready with the input. And what will be my next step? My next step as per the algorithm is to add all these pre-filled values to their corresponding hash sets, and that is done by the initialize sets method. So initialize sets method is here, and in initialize set method, I will be creating a 27 hash set, that is 9 for row, 9 for a column and 9 for a 3 cross 3 subgrid, and totally it is 27 hash set. I will be initializing it, and after that I will be adding each pre-filled value into their corresponding hash set. That is, using the 2 for loops, I am finding the value of a particular cell and I am assigning to the integer number. And if the number is not equal to 0, it means that it is a non-empty value or a pre-filled value. And if it is a pre-filled value, I will be adding it to the corresponding hash set. So this I actually indicates the corresponding row and j indicates the column. And I will be adding it to the corresponding row and columns hash set. And my third step is to add it to the corresponding 3 cross 3 subgrids hash set. So here for a particular cell, we are provided with the corresponding row and column, and we do not know the grid number. So in order to find the grid number, I am using a method called box index of, which is accepting the row number and the column number as the parameter, and it will return the grid number. So now let us consider, and the formula that we use is row by 3 into 3 plus column by 3. So now let us consider an example. So now a task is to find the grid in which the number 6 belongs to. That is 6 belongs to the first row and third column. So logically speaking, it is in 0th row and second column, and our task is to find to which grid 6 belongs to. So now what is the formula that we are using? It is row 0, so it is 0 by 3 into 3, which will yield us 0, plus column is 2, so 2 by 3 will again be 0. So 0 plus 0 will be yielding 0, which means that it is present in the 0th grid. So 0th grid is, it logically belongs to the first 3 cross 3 subgrid. So this is the manner we will be arriving at the grid number from the row and column, and we will be adding it to the corresponding hash set as specified in the last statement inside the if condition num not equal to 0. So our first step is to initialize the hash sets. And what is the next step? The next step is to solve the Sudoku puzzle. So I am having a method called solve Sudoku, which accepts the 9x9 board as an input in order to solve the Sudoku puzzle. So this is actually the solve Sudoku method. So in the solve Sudoku method, then next, what will be my next step? The next step is to find the first empty cell, and I will be replacing that empty cell with some value from 1 to 9 such that it satisfies the constraint. So my first step will be inside the Sudoku puzzle is to find an empty cell. So finding an empty cell, I am using a method called find empty cell, which is accepting the 9x9 board as input. So this is the find empty cell method. So in the find empty cell method, as I have explained in my algorithm, I will be iterating through the rows and I will be finding out my first empty cell. So if a board value is found to be 0, it means that the cell is empty and it will be returning its corresponding row and column index. So it will be returning the row and column index of an empty cell to this solve Sudoku method. And we will be assigning to an empty one-dimensional array which consists of 2 values. So empty at 0 will be my row index and empty at 1 will be my column index of the empty cell. So what if no cell is empty? If no cell is empty, then empty will be null, then we will be returning true. Returning true means that if there are no empty cells, it means that we have solved the Sudoku puzzle successfully, and we will be returning true to our main method and we will be just printing the board. So now what is the case where we do not find, we find the empty cell. So we will be trying to replace it from any of the values 1 to 9. So hence we are iterating through the for loop starting from the number 1 to the number 9. So for each number, we will be checking whether it is valid to place the particular number in the particular cell. So in order to find it, we will be making use of a method called isValid, which is accepting the board, the cell, that is the corresponding row and column of the cell as an input, as well as the number we are trying to place as an input. So it accepts the board, the cell, as well as the number which we are trying to place as an input, and it will be returning whether it is valid to place that particular number in the cell or not. So if isValid returns true, it means that we can place that number in a cell. If it returns false, it means that it is not valid to place that number in a cell. So now let us take a look into the isValid method. So in this isValid method, so as I have said, if a number is valid to be placed, it doesn't that number will not be present in their corresponding row, column and 3x3 subgrids hash set. So that will be the condition that we will be checking now. So we will be checking whether that particular rows hash set consists of the number, columns hash set and 3x3 subgrids hash set. So if all these, we will be checking for all these. So if all these 3 hash set doesn't consist of the number, then we can say that it is valid to place that number inside the board. So isValid method returns true. So if isValid method returns true, we will be replacing the board, that is empty cell, we will be replacing with the number which is nothing but I, and after that our next step will be to add that I into their corresponding hash set, row, column and 3x3 subgrid hash set. This is to ensure that we do not add that number in any one of the row, column or 3x3 subgrid in our further computations. So we will be adding in the hash set, which will be our next step. And after that it will be calling recursively again the solve Sudoku method. So on calling it recursively, we will be checking again. So in our next iteration or in the next recursion step, if we find empty to be null, then what happens? If empty is null, it returns true. So then solve Sudoku of board becomes true. So hence the condition inside if is getting executed, which is returning true to the previous recursive step. So that returns true to the previous recursive step and so on. And finally in the base step, that is the first step, we will be returning true to our main method. And if main method is returned true, then the condition inside if will get executed, that is a board will be printed. So this will actually be our best case, right, where we will be finding the valid number in my first iteration itself and I need not replace any values. So what in case I couldn't find any valid number? So in such case my isValid method returns false. So if isValid method returns false for all the numbers in the range from 1 to 9. So if all the numbers from 1 to 9 are not valid to be placed in a particular cell, so we have observed that case in this particular place, right? So here we have placed 6 and here we are trying to place 7, but 7 is found in column as well as the 3 cross 3 subgrid. That is, any number from 1 to 9, if I place in the place of 0, it leads to the violation of any one of the constraints which is specified. So in such case, what I will be doing? I will be backtracking, I will be replacing the value 6 with some other value. So that is what I will be doing here. So all my values will be false. So since for loop is, so when we come out to the for loop, it will return false to the previous recursion step. So on returning false to the previous recursion step, then what happens is the part which is after the solve Sudoku board will get executed. Since it returns false, then solve Sudoku of board will be false. So the one which is after that will be executed, which is we'll be replacing the value with 0. That is, over there we'll be first replacing the value 6 with 0. Right? So and after that we'll be finding the some other value other than 6, that is we replaced with 7. So that's the one we'll be doing here. So here we'll be making the board 0 and we'll be removing 6 from the corresponding row, column and 3 cross 3 subgrids hash set, and we'll be iterating through the remaining elements. That is, I've seen from number 1 to 6. Now I'll be moving on to the number 7 and I'll be checking whether it is valid and so on. So this happens recursively. And finally, if we reach the solution, then solve Sudoku returns true, and all the in all the recursion steps it becomes true, and finally it returns true to our main method. So what if it becomes false? So in some cases there are conditions where with the pre-filled given input we can't arrive at a solution. So in such case our solve Sudoku method returns false. So if it returns true, it will be printing the board, and if it returns false, else part of the code will get executed, where we will be printing no solution exists. So this is the code execution where I passed all the 3 sample test cases. So in my sample test case, I was able to arrive at a solution for the given pre-filled set of inputs. In my second case, the input was such that there is no solution existing, and I have passed the third case 2, and after that I have passed all the 6 test cases for my submission, and finally we'll be moving on to the final part, which is the complexity analysis. So first of all, we'll be looking on to the time complexity. So we are having the method initialize sets, which is having 2 for loops, which is 9 into 9 time complexity. In a similar way, for find empty cell, we'll be having 9 into 9, and for print, we'll be having 9 into 9. And for main method, since we used for input the 2 for loops, we'll be having 9 into 9 again. So now we'll move on to the major time complexity contributor method, which is a solve Sudoku method, which is a recursive method. So we know that whenever we use backtracking, we'll be making use of recursion, and whenever we make use of recursion, the time complexity leads to be an exponential one. So in a similar way for solve Sudoku, for each empty cell, we'll be trying to place with some value from 1 to 9. So let us consider n to be the empty cell. So for each empty cell, in our worst case, we'll be trying out with all the values from 1 to 9. That is, we'll be checking that whether we can place 1, whether we can place 2, and up till 9 we'll be checking. So hence, our worst case time complexity here will be order of 9 power n, where n is the number of empty cells. So hence the time complexity will be the order of 9 power n. So since all the time complexity is like 9 into 9 and order of 1 time complexity, so these are not the major time complexity contributors. So we consider a final time complexity to be order of 9 power n. And now let us move on to the analysis of the space complexity. So here the major space complexity contributors will be the 27 hash sets, and each hash set capable of holding 9 elements, which is the worst case. So there will be 27 hash sets. And apart from it, we are having a 9 cross 9 board which is given as input, which will be taking order of 9 into 9. So again the major space complexity contributor here will be the board, which is the order of 9 into 9. So hence the space complexity for this problem will be order of 9 into 9. So that is the solution. Thank you all.